Welcome, dear friends. This is a interesting and very simple topic in your air conditioning system. It gives you a good overview of what possibilities exist in the air conditioning systems, what practically we would be looking into as an air conditioning system, and different types of air conditioning systems around us in the real life, and how do you select those, what are the advantages and disadvantages of each. So this would be an interesting brief introduction to the selection of air conditioning system. Well, if you want to select a particular AC system, we need to consider a few of these parameters which are listed over here. I mean, for example, if you are looking for very small capacity systems, then you know that we are going for a window air conditioning system or a split air conditioning system, that is a unitary system. But when you are talking about large systems, central air conditioning systems, then what capacity systems in terms of refrigeration, what space availability exists over that in that plant which is to be air conditioned, how much money we have in terms of capital or initial cost, and how much we are ready to spend in terms of electricity bill, that is the running cost, then the operational issues including the maintenance aspects, and whether it is possible to lay out the ducts or put the pipes, the reliability issues, all this would matter when you are selecting an AC systems. So actually this is not to be learned in theory, as we are exposed to the practical air conditioning installation. We internalize many of these aspects. However, it is a good idea to get exposed to the different types of AC systems and keep this selection criteria in mind. Central HVAC systems or air conditioning systems could be classified into a number of ways. Okay, and we would be dealing not all, but mostly the important ones in our classification and discussion. So one very common type of system wherein the conditioned air, you know that in AC systems we basically have a unit which would condition the cooling equipment or heating equipment depending upon what sort of air conditioning it is. So the conditioned air could be carried straight away to the load, that is the space to be cooled, and depending upon that you might have either a single zone system, a multi-zone system, a single or multi-zone system with terminal reheat, or you might have these first three are single duct systems, or you might also have a dual duct system. In this, mostly we would be keeping the volume constant, so this could be constant volume systems, but at times the air volume need to be varied, and then that becomes VAV, that is a variable air volume system. So all this can be clubbed together into a category called as all air systems. So all air systems means what? You have a air handling unit, and the air handling unit would supply the conditioned air to the space to be cooled, and then the unconditioned air would be carried back, returned back to the air handling unit. So this is generally the layout of all air systems. Okay, so there is no chilled water used in that systems, or there is no hot water used in that systems. So that is all air systems. At times you would find that there is also the chilled water pipes which are laid along with the ducting system. So in those systems you would have a mix of air as a fluid for transferring the cooling effect or heating effect, as well as the water as a fluid which would transfer the cooling effect or heating effect. So you might find that there is a fan coil unit and an induction unit, which is basically where you would have an exchange of heat between the air and the water. So for example, if there is a fan coil unit meant for summer air conditioning, in the fan coil unit you would find that there are chilled water pipes which are flowing, and there is a air which is flowing. There is exchange of heat between the air and water, and this is how you get the cooling and dehumidification process happening. Okay, so in air water systems, you would find both the fluids, that is air as well as water, being used. At times, you would require, or the major load of air conditioning is handled only by chilled water and hot water. Okay, so in such systems, it is not the conditioned air which you are moving around. Okay, so you are basically moving around only the pipes. Okay, and then at local places, you have an exchange between the water in the pipes and the air in the room. Okay, so that is the all water systems. So all water systems would include elaborate network of pipes which would carry either the chilled water or the hot water, or both chilled water and hot water. Okay, so you might have elaborate piping systems in all water systems. And then there are some water source heat pumps, and there are heating and cooling panels, but we will be restricting our discussions to the all air systems, air water systems, and all water systems. In another lecture of mine, I had discussed a bit about the unitary systems. So unitary systems is what? You would have refrigerant directly exchanging the heat with the air to be conditioned. Okay, so this is the broader classification of HVAC systems, and then it would be interesting to know as to which system to choose for a particular application. So as I said, all air systems would include only air as the fluid of heat transfer. In your all water system, only chilled water or hot water, or chilled and hot water are used for the heat transfer for achieving the conditioning effect. And in your air water systems, you use both the water as well as the air for getting the conditioning, right? In unitary systems, as I had mentioned, you would have only refrigerant which is flowing through the piping and achieving the conditioning effect. Okay. If you want to classify it further, okay, then this is one way of classifying it. As I said, we can club the all air systems into a constant volume systems and a variable volume systems. Again, in constant volume systems, you would have further classification as mentioned over here. This could be a single duct system, meaning that in the duct, either you supply the hot air or the cool air. You don't have a simultaneously heating or cooling operation. Okay, because you have a single duct, so obviously you need to supply either the cool air or you need to supply hot air, but there is no simultaneous possibility of heating and cooling because you are using a single duct, right? So you have single supply duct and a single return duct. Okay, that is called as a single duct system. Again, depending upon how you maintain the conditions in the rooms to be conditioned, they could be further classified as single zone systems or multiple zone systems. And if you want to, if you change the volume, though in the title you are written it is a constant volume, but at times you might require to change the volume, and in that case it could be a variable volume systems. Okay, catering either to a single zone or multiple zone. As I said, in the dual duct system, you use simultaneously two ducts for supply and two ducts for return, meaning that you can simultaneously heat as well as cool the given space to be conditioned. Okay. Again, you can classify it further, the dual duct system into a constant volume system and a variable volume system. Okay. Now, let us just focus on what exactly this constant volume single zone system is. As I said, this system is called as a single duct system for a simple reason that there is only a single supply duct. And as I said, in the supply duct, either you supply the hot air or the cold air, but not simultaneously. Okay. Uh, it is also a constant volume system because you maintain the flow rate of the supply air constant. So if you want to cool a particular zone, that you are going to supply a constant volume always, constant volume of supply air always. And then if you are supplying a constant volume of at a given space, then how do you maintain the temperature and humidity? Okay, so you need to put a thermostat over there, and based on the thermostat, based on the control of temperature and humidity ratio, you would see in detail the controls for HVAC system later in our course. But for the time being, just remember that there is a thermostat and there is a humidistat, and that thermostat and humidistat would control the temperature and humidity as a single temperature and a single humidity in a single room. It is not simply that you are saying a single zone is equal to single zone, room. It could be a single zone is equal to single floor. That is a set of rooms. Uh, but then why do you call it as a single zone? Even if there are several rooms, we would call it as single zone if you are maintaining that space, all these rooms at a single temperature and a single humidity. Okay, so that is the way of calling it as a zone. So zone does not necessarily overlap with the room. Okay, we might have multiple rooms as a single zone. So this would clarify what is a single zone system. For example, there are a number of rooms over here, and there is a thermostat and a humidistat which would maintain and give the signals to the cooling coil so as to maintain it at a particular temperature Ti and a particular relative humidity Rhi. You see that there is a single system, single supply duct and a single return duct. Okay, so this is a very simple diagram which would explain us what do we understand by a single zone, single duct system. Okay, and as I said, this zone could be multiple rooms also, but maintained at a particular Ti and a particular Rhi. Okay, that is to be clear. Now, it could be that there are multiple zones. Okay, so you are supplying a constant volume of air to each zone because it is a constant volume system. But then how do you vary the zone temperatures? Okay, so you are supplying from a central AC plant, you are supplying a constant volume of air, right? Then if you want to maintain it at a different parameters, different temperatures, then you need to put in a reheat coil. Okay, so you need to supply it to a reheat coil of each zone. The reheat coil, in the reheat coil, supply air temperature is increased further to a required level depending upon the load on that particular zone. Okay, so this is how by supplying a constant volume, you still maintain multiple zones, okay, multiple temperatures. So this is achieved by a zone thermostat which controls the amount of reheat. Okay, so you have a zone thermostat. In each zone, you would have a thermostat which would control the amount of reheating, and hence there is the supply air temperature is maintained. Now this reheating has to be done. If you are using a reheating, then it has to be done by supplying either electricity, there is an electrical reheater, or you need to supply a hot water in that reheat coil and achieve the reheating. So this process, for example, if you are carrying out a cooling and dehumidification process, so the cyclometric process would be cooling and dehumidification followed by reheating. As you understand that because you are using a reheat coil, this would be more energy intensive. This would consume more electricity as compared to a multiple a variable volume system. Okay, I guess you have understood this constant volume system with reheat. So this schematic would explain you the constant volume with multiple zones. Look at this. This is a cooling coil. This is a heating coil. There is a humidifier. We are supplying this condition here, and a constant volume is being supplied to zone 1, zone 2, zone 3 via the reheat coils. And because these reheat coils are basically controlling this zone temperatures, zone 1, zone 2 and zone 3 temperatures. So these are very critical. Okay, your volumes are same, so you find that the same condition here being supplied to the 3 zones, but still you are maintaining different conditions in zone 1, zone 2, zone 3 by using this zone thermostats, and these zone thermostats are given would give the inputs to this rate coil, and accordingly we can control the water which is circulated in the rate coil or the supply of electricity to the rate coil to adjust these temperatures in the different zones. Okay, so this is single duct. As you see, there is a single duct, a constant volume system. You see that the volume is constant, but there is multiple zone because the temperatures are maintained at a different temperatures, and it is employing reheat for doing this. Okay, a reheat coil is doing this, achieving this. Then, as I said, along with the constant volume, you might think of a system where the volume could be changed. So if the volume could be changed, it becomes a variable volume system. The amount of air supplied to each zone then is controlled by a zone damper. Okay. So you see that there are zone dampers here. In this diagram, it is clear. So this conditioned air is coming and different air flow rates go into the different zones. So in zone 1, you might have a flow rate Q1. In zone 2, you might have a flow rate Q2. In the zone 3, you might have a flow rate Q3. Okay. So different flow rates are possible by putting the dampers over here. Okay. So these dampers are then controlled by a thermostat. So depending upon the temperatures to be maintained over here, your damper position could be set. So these are the controls. You can change, you can set the damper positions by sensing the temperatures is in the zones. Okay. So the temperature of supply air to each zone remains constant, whereas the flow rate varies depending upon the load. So you are supplying a constant temperature of supply air. However, what you are changing is you are changing the flow rate depending upon the cooling load in these zones. Okay. So you sense if the cooling load is more, okay, then that is more heat is to be removed, then you might change this flow rate zone damper and allow more air to flow. If your cooling load is less, then you would allow less air to flow through this. This is how a variable flow system would control and maintain different zones, that is different temperatures within the different rooms. Okay. All water systems, the name itself is very obvious that in this systems, as you see, you would have water lines. You would have water lines, and these water lines go into the different zones, and in the different zones you would have what is called as fan coil unit. Fan coil unit. So this is a fan coil unit, this is a fan coil unit. Suppose this is a summer air conditioning. What would happen in this cooling coil? You would create chilled water at around 7 degrees centigrade. This chilled water would be pumped through this supply water line. This chilled water would enter this zone 1 into the fan coil unit. In the fan coil unit, there would be exchange between the room air and the chilled water, and the room would be cooled and dehumidified. Similarly, this zone 2 would be cooled and dehumidified. So when cooling is required in the conditioned space, then we need to supply the chilled water between the conditioned space and the plant. Okay, and if you want to achieve heating, then you need to supply hot water through these systems, right? And again, these controls are required. You need to sense the temperature inside the room, and accordingly you need to adjust the flow rate of this water in flowing through the pipes. So all this, now there are no ducts here. You would find that the chill pipes, insulated chill pipes, moving across the entire plant, and there has to be a pressure reducing wall. This water is then returned back to the conditioning plant. Okay, conditioning plant. There could be a 2-pipe system. Now this is a 2-pipe system, or there could be 4-pipe systems. So if you want to exclusive cold water pipes and hot water pipes, then you need to have 4-pipe system. If you want to use the same pipe for heating and cooling, then it has to be a 2-pipe system. Okay, so very simple to understand. And then many a times you would require to use both the fluids, that is the air as well as water. So that those kind of systems are called as air water systems. Okay, so from the diagram it would be clear. that you would have a primary air supply and you would have the secondary water supply. So primary air, look at this, there is a central plant which is going to cool the primary air. For example, in summer air conditioning, you need to cool and humidify in this, and then you need to take care of the latent load. You know that in air conditioning, you are handling both the loads, the sensible load as well as the latent load. So the purpose of the primary air is to handle the building latent load. Okay, and then you are in addition supplying the so you have the duct layout as well as you have the pipe layout here. So what would pipe do? Pipe would supply the chilled water here, and the chilled water would offset the sensible cooling load. So water is going to offset the sensible cooling load, and air is going to take care of the latent load. So you would have a ducting system as well as you have a piping systems also in this plant. Okay, since the chilled water coil kept in the conditioned space has to take care of only the sensible load. Okay, so there is no issue of condensation of room air inside the conditioned space. So this is the advantage of using the air water system. What is the advantage? That because the chilled water coil does not take care of the latent load. Okay, so it will not dehumidify the air. It is going to only reduce the temperature of the air. So the condensation of room air inside the conditioned space is avoided. Okay, so this is air water system. So what we have studied now is the different types of arrangements. That is, we have studied the all air systems, we have studied the all water systems, and we have studied air water systems. I have not discussed much about unitary systems. We have discussed this elsewhere. As I said, all air systems, all water systems and air water systems are used in large capacity plants, central air conditioning plants. Whereas if you want to handle small capacities, then you might employ a unitary system. Okay, so this was an overview of the air conditioning systems. I hope the concepts are clear. Thank you very much.